Kristen Schleich again, introducing our next speaker, Paul Danos. He is an architect and a structural engineer here in Ann Arbor, and he is also a general all-around troublemaker. So please feel free to heckle. You're all good for that. Thank you, and welcome, Paul Danos.
Cool, does this work? I have to keep it close, right? That's what they say, keep it close. Okay, go, right away. Well, thanks to the Center for Emerging Professionals for putting on this program. It's really cool. It's great that they have such a wide sense of who artists are and designers are, and that they've brought together such a wide bunch of folks. It's very daring of them to bring on an engineer. I don't want to disappoint anyone. I tried to think of a building style that would be interesting to you. I chose a pre-engineered metal building. That's what we like to call these things. You've seen them on roadsides before. The point is to have a very cost-effective, very simple metal building, and it's good for the owner to have a cost-effective, cheap building. And then we like to do the front end in a way that's decorative and somehow embellished, and the owner just puts the money where they need it. So I got a phone call from a friend one time, and he said, "Hey, Paul, do you want to do a pre-engineered metal building?" I said, "Well, yeah." We talked about it a little bit, and he talked about his ideas. We talked about what his ideas would mean with respect to cost, and what they would mean with respect to schedule, and what they would mean with respect to public safety. The building we ended up with was the Lamar corporate headquarters in Grand Rapids, or Hudsonville, Michigan. And this is it. It's a pre-engineered metal building. The architect was Integrated Architecture out of Grand Rapids. In my office, SBI Structures, we were the structural engineers. Often the structural engineer is one consultant working underneath the architect. In this particular case, we actually had a number of engineers working underneath us. We had, for example, engineers designing for us and working with our team to design concrete mixes. This is not a basement, this is actually a single foundation. The concrete thickness was sufficient that we needed mixes that didn't overheat. We had people helping us to design welds. These welds were tested in the shop, and many of them, when we actually put them into the field, we're going to take a full day of continuous effort to get the welds placed. So we practiced in the shop to make sure they work. We had people helping us design shoring. We had shoring designed out of Grand Rapids, Michigan. So it became a huge team of engineers putting this building together. And then my office designed concrete and steel. It was lots of concrete and lots of steel. As I mentioned, that one footing was rather thick. We put about 100 concrete trucks into that single footing. Steel was put together on the biggest loads we could possibly ship down the road in order to get our steel to the site. So there's quite a bit going on. The architect as well, of course, had things to contribute and things to offer. Oh, I forgot one more engineer. We had vibration engineers. We actually went to Blacksburg, Virginia, Virginia Tech for specialists on vibration to make sure our building was safe and would be comfortable and not a problem for owners. So that was one more engineer we brought on to our team of engineers. Here's what things start to look like. The architect, of course, had a lot to offer. They would create interiors that worked with some of the schemes that we established. Some of these motifs of truss pieces and concrete bases helped to form circulation patterns and became part of the design. The architect picked very thoughtful materials, and that was good to see. Materials that would work well with the concrete and steel that we were involved in. This glass, for example, nice things about the glass. During the day, it might be very reflective and reflect the sky. At night, it might be very transparent. So that's our building. And I put this slide in because it helps to show how the glass can be very reflective at times. And it kind of gets the point across. This is our idea about how you go about fancying up the front end of a pre-engineered building. And it worked pretty well. Lamar corporate headquarters is 90,000 square feet of warehouse space, 7,000 feet of office space, and that's our little office space that we just put up there as kind of a decoration to make the building look interesting. The cantilever is about 125 feet. The cantilever length of 125 feet was based primarily on exit distances. In the code, you have certain requirements with respect to how far you can travel. So the cantilever was basically governed by how far you can safely walk to an exit. The trusses themselves are about 16 feet deep, about 12 feet from bay to bay, and that became the office module, the 12-foot module. The trusses were put in when first installed, cambering up about 3.5 inches cambered up, so that as we added materials and concrete, it would come back down into level. It came back down about 2.5 inches, so actually that building looks like it's straight. It's not straight. It's up by about an inch in 125 feet. We worked hard to get the vibration characteristics correct. Primary consideration is walking, of all things. Walking is a very rhythmic activity, a very patterned activity, where vibrations can be a real problem. So we worked hard to get the frequency of the building a little bit faster than you would walk. We shot for about 2.5 cycles per second, the natural frequency of the building, so that as you were walking in the building, you wouldn't create vibrations that would become uncomfortable. So those are some of the things that went into the building, some of the ways we chose to approach the problem that we had. We had a really remarkable team of people who were very daring and very willing to experiment, very supportive. It was a team that was just a real pleasure and speaks very well for good collaboration. So thanks for listening to my presentation. I'm glad that you can learn a little bit more about the pre-engineered building, metal building, and how we work on them, and hope you have a very good evening. Thanks very much.
Thank you, Paul. More than I ever needed to know, maybe, but really, really cool.